All right, let's crank this out. Find the simplified quotient. That's just a fancy word. Good old-fashioned trinomial, two factors of negative 18 that up to negative 3, x minus 6, x plus 3, times. I'm going to factor this and put it in the top. That's x plus 4, x plus 3. Factor this guy, put it in the bottom, xx, and then two factors. You can do that before you start canceling stuff. So x cannot equal 6, cannot equal negative 3, cannot equal negative 6, and cannot equal 4. Now we can cancel things. So x minus 6, x minus 6, x plus 6, x plus 6, x plus 3, x plus 3. Now you got x plus 4 all over x minus 4. Now be careful, you can't cancel these out. Equals negative 1, and that's true. But this is not that case, because these are the same, these are opposites. There's nothing you can do. You might be tempted to think of it like this, but they're not the same things. All right. So number 17, take a look at this. They tell you the area of a rectangle. I want to talk equals length times width. Your brain would somehow need to go 100 equals 20 times W. 20 times what is 200. You could just see that it's 5 divided by 20. The width is 5. 5 times 20 is 100. So they give it to you in an algebraic way. You just have to plus 8, so there's the length. So we need to think, okay, the area, 25x cubed plus 200x squared, that's the area, equals the length, x plus 8, times this mystery w, they're asking for the width. So you got to divide by x plus 8. Answer simplified as possible. So we take a look at this. We can take out a 25. Don't forget that. Look at the numbers. X squared, and we'd be left with x plus 8 over x plus 8. So adding and subtracting fractions, that's what it's really saying. And it says state the domain. You should do that right away. X cannot equal negative 6 and x cannot equal 1. All right, so get that started right away. Find the sum. We've got to find common denominators, so I'm going to multiply that by what it doesn't have, x plus 6. That's a 6, and this is x plus 6. Distribute 2x squared minus 2x all over our common denominator plus distribute 3x plus 18 all over our common denominator. So now we're going to add like terms. So 2x squared is by itself, negative 2x, and 3x is is 1. Now you'd think you're done, but you got to be careful on these. About 1% of the time, if you factor this, when you get a trinomial like this, one of these things might cancel. So let's just take a second, do our old school. This might not even factor. Nothing does, so we're done. This one here, you got a little work to do before you get started. This is a difference of 2 squares, so x minus 2, x plus 2. And this would now need an x plus 2 in order to match these common denominators. So then this would be x plus 2. This guy doesn't change, so it's x over x minus 5 minus 2 x plus 2. We did that so that we could add our numerators. So that'd give us 6x plus 10 all over x minus 2 x plus 2. And like I said, 1% of the time, every now and then, your numerator that's factorable, and then you're going to be able to hack something. So you can see I can take a 3 out of this, or a 2, and I'd be left with 3x plus 5. This as your answer, or this factored version as your answer, because they're both the same, and there you go. Now we're solving, a little different. Well, the first thing we should look at is this possibility, which is like, what can't x be? X cannot equal negative 4, because you can't have a 0 down there. X plus 4 multiplied by x plus 4. These cancel, so I'd be left with 18, distribute, 6x plus 24. Subtract 24. Similar problem here. Start right away by saying what x cannot equal, just to get your brain in the right space. Can't equal 1. Now we're going to multiply by x minus 1, because those cancel. And then multiply this by x minus 1. Sorry about the mess. So 9 equals, distribute, 3x minus 3. Add 3, 12 equals. Take a look at the 3, take a look at the x. This plus, I'm going to put plus a minus so I don't get confused by it. I'm going to multiply by the least common multiple, which is 3x. So I multiplied that by that so that this would destroy the denominator. So and then this hits this. Now this is going to get tricky, but this x would cancel with this x, and then I'd be left with 3 times 2, which is 6. Then this hits this, and this time the 3 cancels with that 3, but the x is still alive, so x times negative 4 would be negative 4x plus 6. So I'm going to add 4x, add 4x. Okay, so we got x plus 3, x plus 3. We don't want them. So we multiply this whole thing by x plus 3. So when this hits this, if you want to put it in parentheses to help your brain a little bit, those would cancel. If you end up getting this as an answer, then it would qualify as an extraneous solution. But now we got to do the work. Plus. Well, this now hits this. There's a 1 down there, so it doesn't cancel with anything. So you distribute the 5 through there. You get 5x plus 15. And up and subtract 7x just to gather my x's. You don't have to do it exactly like this, but and I get negative x. So then I multiply this by negative 1, so x is negative 15. Because this isn't my extraneous, this is my solution with no extraneous solutions. Okay, final push. X minus 8, a little more difficult. You can see it's coming, but so this hits this, they cancel. You're left with x squared. This hits this. Don't forget the equals. These cancel. So 64. This hits this. Nothing cancels because there's a 1 down there, so you distribute the negative 8 through. Let's see. So negative 8 times x is negative 8x. Negative 8 times negative 8 is 6. Help you. So let's clean this up. Negative 8x plus 128 equals x squared. Don't subtract x squared from both sides because that would make it negative. So let's bring all these goodies over to this side. Whoops. Give me a second so I don't waste all your time. Okay, so I started hammering out possibilities, but I know they wouldn't work. So you can see the difference of these are huge. We needed to get closer and closer to 8, so I resorted to the handy-dandy calculator, and I went winner chicken dinner. This was a little bit more difficult. Well, a lot more difficult. So we need the bigger number to be positive, so that would be plus 16 and then minus 8. And so our possible answers are negative 16 or 8. Now remember, x can't equal 8. That's why you did that. This is an extraneous solution. On attack mode, so that's what we're dealing with here. And just there's multiple ways to do this kind, but I'm going to stick with what we've been doing. We've been getting rid of denominators. So what I'm going to do is rewrite this. So you can see I'm going to go ahead and just take a look at this, but whenever you can reduce, you should. And this right here, 3, 6, I should reduce that to 1/2. That's why I'm saying there's quite a few ways to do this. But what an x minus 3 and an x minus 3. So I'm going to multiply by x minus 3 because I want those to absorb. But I have a 2 here, so I'm going to multiply by the 2. And I have an x plus 3 over here. I'll just put it here because I'm running out of space. Three. Then this whole glob comes over here and hits this, so the x minus 3's are gone, x plus 3's are gone. You're left with 2 times 9, which is 18. And now it's super simple. X is 15. I did forget to talk about what x can't equal. X cannot be 3. So number 26, we've been kind of explaining it the whole way, so I'm kind of confused about this question, but it says explain how to check if a solution is to a rational equation. That's what this is. That's what this is an extraneous solution. And really, if that's one of your solutions, then that would qualify as an extraneous solution. Just like this. X can't equal 8. One of our solutions was 8. That identifies it as extraneous. It's an answer, but it's not a mathematical possibility.